Exercises 1 through 6, we want to use the graph to determine the limit and then discuss the continuity of the function. So the three limits that we're looking for is the limit as x approaches c from the right of f of x, limit as x approaches c from the left of f of x, and the two-sided limit as x approaches c of f of x. So in problem number 1, c is equal to 4, and so we want the limit as x approaches 4 from the right, and that is just 3. Then the limit as x approaches 4 from the left, and that is also 3. And finally, the two-sided limit is 3 as well. Now finally, we want to discuss the continuity of the function continuous on all real numbers, for all real numbers. And so its continuity is from negative infinity to positive infinity. For number 3, c is equal to 3. So we want the limit as x approaches 3 from the right, and that will be 0. The limit as x approaches 3 from the left, it's also heading for 0. Doesn't matter what the value of the function is, even though the value of the function is at 1, the left side and right side are both heading for 0, and therefore the two-sided limit is also 0. Now this function is continuous on the open interval from negative infinity to 3, and from 3 to positive infinity. So I'll scroll down and we'll look at number 5. With problem number 5, our c value is 2, and so we want the limit as x approaches 2 from the right of f of x, so that would be negative 3. Then we want the limit as x approaches 2 from the left of f of x. This time that would be positive 3. And since the two one-sided limits disagree, the two-sided limit does not exist. Discussing the continuity, the function will be continuous from negative infinity to 2 on an open interval, and from 2 to positive infinity. We can say that that has a jump discontinuity, whereas in problem number 3 there was a removable discontinuity. Okay, I'll scroll down to look at problem number 7. Right, in 7 through 26 we want to find the limit if it exists, and if it doesn't exist we want to explain why. So what we're working with here are one-sided limits. But with one-sided limits the same principle applies. If we can plug in the value of the limit, in this case number 7, as x approaches 8 from the right, if we can just plug in 8 in there and it doesn't cause the denominator to go to 0, then that's all we really have to do. We don't have to worry about the fact that it's from the right or from the left. That's not going to affect the outcome. So in this case, if we were to just plug in x equals 8, we're going to get 1 over 16. Now in problem number 9 we have a slightly different issue, because plugging in 5 in the numerator gives 0, plugging in 5 in the denominator also gives 0, so that's a different story. So in this case we want to pick a number that's close to, in this case then we want to try to use our different strategies for simplifying this, and we should be able to factor and cancel here. So here we can factor the denominator to be x plus 5 times x minus 5. We cancel the x minus 5's, and we end up with the limit as x approaches 5 from the right of 1 over x plus 5, and that's just the same type of problem that we saw above. We plug in 5 and get 1 over 10. And of course these can all be verified on your calculator using only numbers that approach 5 from the right. I'll continue with number 11 and 13 in the next video.